Advanced math, powers of trigonometric functions and perpendicular bisectors. So, these are the three ways to write powers of trigonometric functions. These first two are in blue because these are the ones we're going to use. The last one is in red because I don't really know anyone that uses this. Technically, this is mathematically correct. What this is saying is, if we had a key that said, theta equals 30, what this means is sine of 30 squared, which is like 900, which is the sine of 900. We would just write the sine of 900. You've seen that before. There's no reason to put exponents to your thetas, your angles. So this one is in red because we will not use it. The one we will use are these two. And these are two different ways of writing the same thing. So keep your eye out for both of them. And what this means is the sine of theta squared or sine squared of theta. That's how they're read. They both mean the exact same thing. So then let's go ahead and say that theta equals 30 degrees. The sine of 30 degrees is going to be 1/2, right? So let's go with green. All right. So what this means is that if we plug 30 degrees into sine, we'd have sine of 30 squared, or we would have sine squared of 30. We know from our 30, 60, 90 reference triangle that sine being opposite of our hypotenuse is going to equal 1/2. So then what we actually have here is 1/2 squared, or in this case, this would simplify to the same thing, sine squared of 30. So sine of 30 is 1/2, so it'd just be 1/2 squared on both of them. So two different notations for writing the same thing, and this is what they mean. You find the angle, you calculate the sine of that angle, and then you square it. You could also put a cube in there. So, so you square a cube or apply the exponent to whatever the trigonometric value of the angle is. So let's do a practical exercise. Okay. So we have the cosecant squared of negative 405 degrees minus the tangent squared of 45 degrees. These angles don't need to be in parentheses, but they can be, and I did because I wanted to. Take that. Okay, so first let's start with some simplification. Cosecant, which is actually 1 over sine. So this is actually 1 over sine squared of, and then we'll go with angle negative 405. So if we go negative 360, and 405 is actually another 45, so this is the same as negative 45 degrees. So this is 1 over the sine squared of negative 45 degrees. And then we have minus the tangent squared of positive 45 degrees. So let's go ahead and draw our 45-90 right triangle. And then for our sides we have 1 root 2. Sine being the opposite over the hypotenuse, so this is going to be 1 over root 2 squared. So 1 over root 2 times 1 over root 2 is just going to equal 1/2, and then this is 1 over that, so what we have on this side is 1 over 1/2, which inverts to just become 2. So cosecant squared of negative 405 degrees is 2. Now let's find tangent squared of 45 degrees. So tangent of 45 is going to be opposite over the adjacent. Opposite is 1, adjacent is 1, so we just have 1, and then apply the squared. 1 squared, big surprise, equals 1. So tangent squared of 45 is just 1. So 2 minus 1 equals 1. Don't you love these trig problems? We do all this work just so we can write down 1 or negative 1 or 3 is our answer. I think it's fun. Okay, so that's powers of trigonometric functions. That's how we're going to use them. let's talk about perpendicular bisectors. This is going to take a bit of explanation. So the problem we're going to be given is to find the equation of a perpendicular bisector of a line segment whose endpoint coordinates are 4, 2, and 8, negative 3. So we'll go ahead and write these coordinates down. We have 4, 2, then we have 8, negative 3. If I graph these, let's say this is 1, 2, 3, 4, 1, 2, that's 1 point, and then 5, 6, 7, 8, 1, 2, 3, that's going to be the second point. So that creates our line segment. Now we have to graph the perpendicular bisector. Now in order to find the perpendicular bisector, we have to find the midpoint of the two lines. And to do that, we're going to use midpoint formula. If you do not remember, midpoint formula is this. Midpoint is going to equal y2 minus y1 over, or what, no, sorry, I'm looking at slope. I'm thinking slope formula. Hold on, my fault. Okay, yeah, sorry, I'm thinking the slope formula. It's not minus, it's plus. Okay, so that's not m, that's y. So for midpoint formula, y is going to equal y2 plus y1, or y1 plus y2 divided by 2, and then x is going to equal x1 plus x2 divided by 2. So again, midpoint formula, pretty simple. We'll plug in our y amounts, which are 2 and negative 3. So 2 plus negative 3 is negative 1. So y is going to equal negative 1/2. And then our x amounts are 4 and 8. So 4 plus 8 is 12. 12 divided by 2 is 6. So x is going to equal 6. Let's check this on our graph. If we go 1, 2, 3, 4, 5, 6, negative 1/2, that looks about right. I think we're at our midpoint. Cool. So midpoint is negative, I'm sorry, x and then y. Our midpoint is 6, negative 1/2. Okay. So now what this problem becomes is we have an existing line, we have a point that the perpendicular line will run through, and then we have to find the equation of that particular perpendicular line. So this is pretty similar to previous perpendicular line problems we've solved. We're just adding some extra elements. So first thing, we have to find the slope of this existing green line. We have these 2 points for the existing green line, so to find the slope, we'll use slope formula. Now we're using slope formula. Whoops, I wanted to write midpoint formula. I almost put a y. Okay, so m is going to equal y2 minus y1 over x2 minus x1. Again, the order of x and y are unimportant. What matters is consistency. So when I plug in some x's and some y's, what I get is negative 3 minus 2, and then I get 8 minus 4. So negative 3 minus 2 is negative 5. And then 8 minus 4 is 4. So negative 5/4 is the slope of the green line. So if the slope of the green line is negative 5/4, the slope of the perpendicular line is going to be the negative inverse. So the negative inverse being positive 4/5. So this is positive 4/5. And I know that because the lines are perpendicular. So this line that I'm looking for, right now I have y equals 4/5 x plus b. Do not know what b is. So to find b, I'm going to take 2 points that my line passes through, plug them in, and solve for b. So we'll do the substitution in blue. When I substitute, my y is negative 1/2 equals 4/5 times 6 plus b. I have to do a little bit of fraction work here. 6 times 4 is 24 over 5. And then I'm going to subtract that from each side. This will cancel. And then I will have b equals whatever 1/2 plus negative 24 over 5 is. So let's do that over here. This is going to become, well, yeah, we can just do that. Well, yeah, we'll do it like this. No, that's silly. This will become negative 5 over 10, because we multiply by 5 over 5 or 1. This one is going to multiply by 2 over 2, which is going, why did I put a plus sign there? That's a negative. Negative. This one is going to become 48 over 10. So negative 5 minus 48, negative 53. Yep, negative 53 over 10. That's going to equal b. And so then I'll plug that into here to get my final answer, which is going to be, whiteout is cool, is going to be negative 53 over 10, and that is my final answer. I just realized it doesn't come in as dark. It's weird. Okay. This is my final answer. The book has the answer written in decimal form, so it says y equals 4/5 x minus 5.3. Same number. I'm not going to split hairs over that. But that's how we use that's how we find perpendicular bisectors. So use midpoint formula to find the midpoint. Use slope formula to find your slope. Take the negative inverse to find the slope of your perpendicular bisector, and then plug the midpoint into that equation with that slope to solve for your y-intercept, and you're good to go. If you have any questions, let me know on Moodle, and I will see you in class.